dear learners, welcome to this session on marketing research. As we have seen in earlier session on marketing research process, that data collection and analysis are important steps in the marketing research process. Marketers collect and maintain customer information, and this database is used for the formulation of marketing plans and strategies. However, as internet and communication technologies have advanced, the availability and method of data generation have significantly changed. The use of social media and mobile technologies results in the generation of significant amounts of unstructured data, including unformatted textual, graphical, audio, and video data. Additionally, a significant amount of semi-structured data is being generated at a significant rate due to the remarkable expansion in the digital ecosystem of organizations. As a result, data is available in a very large quantity and a variety of formats. And this is where the idea of big data is introduced. In this session, we will discuss the various aspects of big data and its application in marketing research to support decision makers in making well-informed decisions. The learning outcomes of this session are: explain big data and its characteristics, discuss the characteristics of structured, semi-structured, and unstructured data, then explain the role of big data and marketing research, illustrate the concept of big data and marketing research with the help of case example. So let's first see what is a big data. Big data can be understood same as data, but it is present in very huge amount and number. It consists of the information provided by both humans and computer. Big data is so large and complex in its size and storage that it is unable to be decoded and understood efficiently by the traditional data management tools. Every digital action we take, from searching online to using apps, creates a digital trail. This vast amount of data is growing exponentially, especially with the rise of Internet of Things, IoT. It comes from a diverse range of sources like websites, customer databases, transactional systems, social media platforms, and machine-generated data, and so on. This data includes various formats such as text, numbers, images, videos, and even real-time streaming data. In simple words, big data can be defined as data that has a wider variety, arrives at a faster rate, and arrives in higher quantities. Such data can be collected through various sources such as blogs, comments, app permissions, online surveys, virtual check-ins on e-commerce portals, etc. Because of the vast amount and the high level of complexity, none of the normal methods that are used for managing data can effectively store or deal with such data. So, big data refers to a collection of information that is not only extremely large in quantity but also growing at an exponential rate over the course of time. Big data is often stored in computer databases and it is analyzed using specialized software. Now let us see the characteristics of big data in order to know how the concept of big data works and how it can be used. Characteristics of big data are commonly described by 9 V's in terms of volume, velocity, variety, veracity, variability, value, validity, volatility, and visualization. We will discuss these V's of big data one by one for better understanding and effective utilization of this data. So let's first see the volume. The most frequently mentioned characteristics of big data is volume. This data keeps growing rapidly in business, coming from various sources like real-time processing systems, user clicks, and system logs. Notably, Big data often involves vast quantities of unstructured, unrefined information. Think of social media feeds, website clicks, or sensor data. These are all examples of big data. So, to measure these huge data sets, we use units like gigabytes, terabytes, petabytes, exabytes, zettabytes, and yottabytes. Depending on the company, the data volume can range from tens of gigabytes to hundreds of petabytes. The sheer size of data plays an important role. The more data you have, the more potential insights you can extract. The second characteristic is velocity. Apart from huge size of data, data speed also matters. Velocity refers to the speed of data generation, how fast this data is generated and processed to meet customer demands and requirements in real times. Unlike traditional data storage methods, high velocity data often bypass storage and is processed directly in memory. This is essential for applications requiring real-time analysis and decision making, such as internet-connected devices. The continuous and accelerating generation of data poses significant challenges. For example, in just 30 minutes of flight, a single jet engine produces more than 10 terabytes of data. Imagine the immense volume of data required to analyze even a small airline operation. When it comes to the efficiency of any operation involving vast amounts of data, a high velocity is a fundamental requirement. These characteristics can be broken down into its component parts, which include the rate of change, activity burst, and the linking of incoming data sets. The next characteristic is variety. Big data is generally heterogeneous. Variety refers to the diversity of sources of data, both structured and unstructured. This mix includes structured information like transaction records and unstructured data such as emails, documents, and images. Managing and analyzing such different data types is a significant challenge. Before extracting valuable insights, this data must be categorized and organized. Big data projects often involve combining multiple data sets that do not initially fit together. For instance, predicting product sales might require analyzing sales data, returns, customer feedbacks, and support calls. This complexity hampers the efficiency of analysis. To effectively handle big data, it's essential to organize and manage this variety of information from different sources. Next characteristic is veracity. Veracity refers to the trustworthiness and correctness of data. Using raw data from various sources can lead to significant data quality issues, which are often difficult to detect. Data cleansing is crucial to address data quality problems arising from raw data, as inaccurate data can undermine the value of business analytics initiatives. Having enough reliable data is important for producing dependable results. Data accuracy is essential for drawing precise conclusions. It's a critical aspect of big data. Next characteristic is variability. Data variability describes the rate and extent of data fluctuation. In the context of big data, inconsistencies and discrepancies across diverse data sources significantly complicates this challenge. The dynamic nature of data can compromise data homogeneity, impacting the reliability of analytical outcomes. Consequently, high data variability necessitates frequent reassessment of results. Next characteristic is the value. The value an organization derives from data is the benefit it gains from using it. To be effective, big data analysis must align with the company's objectives and contribute to its growth. This means extracting meaningful insights using specialized tools to achieve specific goals like improving customer satisfaction or increasing sales. Understanding customer behavior through data is important for developing targeted marketing campaigns and boosting business performance. Next characteristic is the validity. These characteristics of big data relates to how valid and pertinent are the facts that are going to be used for the purpose that they are designed for. It includes the data's accuracy, reliability, and appropriateness for drawing meaningful conclusions or making informed decisions. Essentially, it measures how well the data aligns with the specific goals and objectives of the analysis. Valid data is important for ensuring the credibility and utility of insights derived from big data. Next characteristic is the volatility. Volatility relates to the lifespan of big data. Some data items may be valid for very short duration, like the sentiments of people. Then the visualization. This is the next characteristics. It means able to express the insights that were generated by big data by using visual representations such as charts and graphs. As the target audience for these insights expands to include individuals without technical expertise, the effective use of visual representation becomes increasingly important. After knowing the characteristics of big data, now let's discuss the classification of big data. There are the three varieties of data that are becoming increasingly important for many kinds of commercial applications, and these are structured, semi-structured, and unstructured data. While structured data has been the backbone of traditional systems, the surge in unstructured and semi-structured data has created new opportunities. To maximize insights and competitiveness, organizations are incorporating all three data types into their business intelligence and analytics platforms. Now, we will explore data classification in the context of big data and differentiate between structured, semi-structured, and unstructured data formats. So, structured data is defined as data that can be collected, saved, retrieved, and processed in a specific format. It is simpler to organize and analyze structured data since it has some predetermined characteristics. This data is typically stored in databases or spreadsheets where it's arranged in rows and columns. Unlike unstructured data, it's well defined and follows a specific structure. Examples of structured data include sales records, financial data, and customer information. Structured data can be analyzed easily because it corresponds to data models that have already been defined. For example, you can organize structured data such as names of customers in alphabetical order, organize telephone numbers in the appropriate format, organize Aadhaar number in the correct format, etc. Because of its organized nature, it's available for business as it can be easily processed to extract meaningful insights. So, the key characteristics of structured data are it follows a specific data model, it can easily accessible and retrievable using SQL, it reduces data redundancy, it dependent on its structure and limiting flexibility. Created by both humans and machines, simple to analyze due to its predefined format, can be easily sorted, filtered, and manipulated. Examples of structured data: spreadsheets, sales transactions, point of sales, terminal data, customer records, and so on. Now let's see what is unstructured data. Unstructured data refers to information that lacks a predefined data model or organization. It is the primary source of big data but presents significant challenges in analysis due to its inherent complexity. Examples include Google search results, text documents, images, videos, audio files, and social media content. Unlike structured data, while follow a rigid format, that means the structured data follows a rigid format. The unstructured data exists in a raw, unprocessed state. To extract value from this vast resource, organizations employ unstructured data management technique to organize and store information from diverse sources such as social media platforms, IoT devices, and online content. Essentially, unstructured data is information in its original unprocessed state. Its lack of structure hinders traditional data processing methods, but advanced technologies are being developed to harness potential of unstructured data. Key characteristics of unstructured data are lack of structure, no predefined data model or schema or plan, and then variety of formats, text, images, videos, audios, and more. High volume contributes significantly to big data complexity, difficult to interpret and analyze due to its unstructured nature. Then origin, primarily generated from human interactions and digital activities. Applications of unstructured data includes the customer insights and sentiment analysis, such as social media monitoring, for analyzing customer sentiments, preferences and trends, the market research, understanding customer behavior and preferences, then reputation management, tracking brand mentions and addressing negative feedback, then search engines and information retrieval, such as improving search results by understanding user queries and delivering relevant information. Then recommendation systems, suggesting products, content or services based on users' preferences. Now come to the semi-structured data. This semi-structured data occupies a middle ground between the rigid structure of traditional databases and the amorphous nature of unstructured data. Characterized by a partial organization, it exhibits both defined and undefined elements within its structure. While not conforming to the strict plans of relational databases, semi-structured data often incorporates metadata or semantic tags for improved manageability. Examples include web server logs, sensor data, and web application data, which often contain structured components but lack the overall rigidity of structured formats. Delimited files and digital images serves as illustrative examples of semi-structured data. While the core content of a digital image is unstructured, associated metadata such as device information, geolocation, and user-applied tags introduce structured elements. Similarly, delimited files possess a defined structure for data separation but lack the orderly rigidity of relational databases. The characteristics of semi-structured data are it is the no rigid schema, although there is no rigid schema or plan. Unlike structured data, it does not adhere to a predetermined schema, offering flexibility. Then combination of structured and unstructured, it blends elements of both structured and unstructured data. Then metadata or tags, uses metadata or tags to organize and provide context, making it more manageable than unstructured data. Hierarchy often exhibits an orderly structure. Then partial consistency, while it has some organizational elements, inconsistencies can still exist within the data. Then flexibility, it can accommodate changes in data structure over time. Then human readable, frequently in a format that human can understand. Semi-structured data has a wide range of applications across various domains, such as in web development, data interchange, log files, sensor data, and in data from social media platforms. After knowing characteristics and classification of big data, now let us discuss the role of big data in marketing research. As we have discussed in earlier sessions, that the purpose of marketing research has been to distinguish research problems from decision problems, and as a result collect data and analyze it into information and insights that are useful to decision makers. But the emergence of big data has complicated the process of understanding and assessing markets. Big data is so vast and varied that conducting marketing research requires a more comprehensive strategy. To know how big data analytics and traditional marketing research differ and complement each other in answering modern business challenges, it is important to learn more about their main differences. Now let's discuss the main distinction between marketing research and big data analytics. So first is the data volume and complexity. A fundamental difference lies in the scale and complexity of the data. Big data includes vast quantities of structured and unstructured information, exponentially growing due to technological advancements. On the other hand, data sets used in marketing research are usually easier to handle. The large volume of big data demands specialized tools and techniques for analysis, while marketing research can often rely on established methodologies. The second point is real-time analysis and predictive capability. Big data analytics is good at real-time analysis, making it possible to see trends and patterns as soon as they appear. Forecasting and predictive modeling are made easier as a result. Conversely, marketing research is typically retrospective in nature, emphasizing the understanding of past attitudes and behaviors to guide future strategies. Next is depth of insight. Marketing research goes deeper into the underlying motives and preferences of consumer behavior, whereas big data offers a wide perspective of it. Qualitative research methods such as focus groups and in-depth interview complement quantitative big data analysis by providing rich contextual information. The next is focus and application. Big data analytics often serve as exploratory tools, identifying potential opportunities or threats. Marketing research, conversely, is typically problem-oriented, addressing specific business questions. So we can say that big data analytics and marketing research are complementary approaches. While traditional marketing research delivers significant depth and context, big data offer unprecedented scale and speed. Combining the two approaches in a synergy way, we can provide insightful information for well-informed decision making. Now takes an example for better understanding of this role of big data in marketing research. So big data analytics can predict future customer behavior based on past pattern. For example, if Mr. Sanjeev consistently orders groceries on Wednesdays between 4 and 6 p.m., we can anticipate similar behavior. Additionally, we can tailor offers based on his usual purchases or purchase behavior. However, big data cannot explain why customers behave as they do. People and their circumstances changes. So unexpected actions cannot be foreseen using the big data alone. For example, we would not know why Mr. Sanjeev suddenly shops on a Friday or take a break from grocery shopping. This is where market research becomes invaluable. It helps us understand the reasons behind customer behavior and adapt our strategically accordingly. Let's further discuss the use of big data and marketing research in the context of this Mr. Sanjeev's grocery shopping. In Mr. Sanjeev's case, a tool called as market basket analytics can be employed to identify frequently purchased items. By analyzing his purchase history, the retailer can determine the products Mr. Sanjeev regularly buys. This information can be used to create personalized offers and recommendations. Then discover product affinity. The analysis can reveal which products Mr. Sanjeev tends to purchase together. For example, if he often buys milk and bread simultaneously, the store can offer bundled discounts or place these items closer together on shelves. Then optimize shelf placement. Understanding which products are frequently purchased together can help optimize store layout. By placing complementary items near each other, retailers can increase sales. However, while market basket analytics provide valuable insights, it has limitations such as lack of predictive power for behavioral changes. It cannot explain why a customer's behavior changes, such as Mr. Sanjeev shopping on Friday instead of his usual Wednesday. Then next limitations can be incapability to account for external factors. The model cannot consider external factors influencing purchase decisions like promotions, holidays, or weather, etc. Here comes the role of marketing research. To complement market basket analytics, market research can provide deeper insights into customer behavior, such as understanding motivations. Researchers can explore why Mr. Sanjeev changed his shopping habits, uncovering underlying reasons like a new job or a family event. Then it can be identifying emerging trends. Market research can help identify broader trends that might impact Mr. Sanjeev's behavior, such as a growing preference for online grocery shopping. Then it can be gathering feedback. By conducting surveys or interviews, retailers can directly gather feedback from customers like Mr. Sanjeev's, helping to refine marketing strategies. So we can say in this case, market basket analytics offers a quantitative approach to understanding customer behavior, while market research provides qualitative insights. Combining both methods can lead to a more comprehensive understanding of customers and improved marketing effectiveness. So, with this, now we can conclude the session. In this session, we have discussed the characteristics of big data and its role in marketing research. Big data is characterized by its vast volume, rapid velocity, and diverse variety. We have described the 9 V's of big data. Then it's sourced from various digital platforms like blogs, social media, and online shopping sites. Due to its immense size and complexity, traditional data management methods are inadequate. We have explored different types of big data, including structured, semi-structured, and unstructured formats. Basically, big data analytics and marketing research are complementary to each other. While traditional research offers in-depth insights, big data provides a broad and rapid overviews. By combining these approaches, we can make informed decisions based on comprehensive data analysis. So, in this session, we have explained big data and its characteristics. We compared the characteristics of structured, semi-structured, and unstructured data. We explained the role of big data in marketing research, illustrated the concept of big data in marketing research with the help of a case example. Now, let's check your progress. Question 1 is, big data is characterized by its option A, small volume, high velocity and low variety, B, vast volume, rapid velocity and diverse variety, C, medium volume, slow velocity and limited variety, and D, none of the above. Question 2, big data is primarily sourced from A, traditional data warehouses, B, digital platforms like social media and e-commerce, C, government records, D, all of the above. Question 3, which of the following is not a type of big data format? Option A, structured, B, semi-structured, C, unstructured, D, highly structured. Question 4, traditional data management methods are often inadequate for big data due to its option A, small size and simplicity, B, immense size and complexity, C, low volume and variety, D, none of the above. Question 5th is, the relationship between big data analytics and marketing research can be described as a competitive, B, complementary, C, independent, D, opposite. So with this, we end the session here. Thank you. Happy learning.